Hello friends, welcome back. In this session, quickly, we will understand the GPT and BERT architecture. We will understand the significant differences between these two. I'll also walk you through a couple of very simple examples, the codes which can explain you how exactly BERT works. It's going to be very simple yet very important and easy. Well, before we go in depth into BERT or GPT, it is very important for us to understand what is a transformer. A transformer is the key element here, and transformer in fact is going to be the fundamental thing for all whatever we are going to learn. A transformer is a type of deep learning model architecture used primarily in NLP tasks and applications. The key innovation of the transformer models is the feature called as self-attention mechanism. The self-attention mechanism allows the model to weigh the importance of different words in the sentence when processing each word. I repeat, the most important feature of the transformer is that self-attention mechanism, and the self-attention mechanism enables the model to weigh the importance of different words in a sentence when processing each word. This mechanism enables and facilitates the model to capture the long-range dependencies in the input sequence more effectively and efficiently compared to the previously available historical architectures like the RNNs or the CNNs. What makes the transformer very special is the ability to pay attention to different part of a sentence. That's most important. For example, when translating a sentence from one language to another, the transformer knows which words in the input sentence are important for understanding the meaning, and it focuses on those particular words. The attention to detail helps the transformers to do a great job on tasks which are related to the translating languages, answering questions, summarizing articles, etc. So please remember, the attention is most important thing. Here, the self-attention mechanism makes the transformers really super. The transformers consist of an encoder-decoder architecture fundamentally, where the encoder processes the input sequence and the decoder, as you know, generates the output sequence. Each encoder and decoder layer in the transformer contains multiple self-attention layers and feed-forward neural networks. I have already explained what is a feed-forward neural network in my previous videos. If you have any questions, you can go ahead and understand what is that. The popular transformers which are very commonly used and we are well aware of is BERT, GPT, Rabata, T5 and many others are there, and in this session we are going to discuss the GPT, the generative pre-trained transformer, plus the bidirectional encoder representations from transformers, which is called as BERT. We will understand the architecture. We will see some fundamental details about that which will enable you to understand the differences between the GPT and the BERT architectures as well. We are going to get into GPT first. We will understand the architecture. Then we will get into BERT. What is GPT? GPT is generative pre-trained transformer, and it is a type of machine learning model developed by OpenAI. We all know what is ChatGPT. ChatGPT uses GPT as the fundamental thing, and it's designed to understand and generate human-like text based on the input prompt that it receives. The transformer architecture is so very crucial in the GPT. It is a type of neural network architecture again, and it is very effective for the sequential data like text. I have already detailed you as in what is transformer. Transformer uses the attention mechanisms, and that's going to be very helpful to weigh the importance of different words in a sentence when processing them, and thereby allowing them to capture the long range dependencies and understand the context very clearly. So with that input, we can get into GPT's architecture. The pre-trained aspect means that the GPT is trained on a vast amount of text data before being fine-tuned for specific tasks. This pre-training phase is very important, and that helps the model learn the nuances of the language and develop a broad understanding of various topics. GPT models have been trained on a very large amount of datasets like books, articles, websites, and this allows them to generate coherent and contextually relevant text across varied topics. So GPT models are very well known for their ability to perform various language related tasks which can include the text generation, the translation, the summarization and many more. Let's get into the GPT architecture in a very simple way. First is input. You start with some text input. You are feeding some prompt input. This could be a sentence, a paragraph, or a longer piece of text. The next immediate step comes into picture is tokenization. The text that you have fed in is split into smaller parts called as tokens. These tokens could be words or even smaller units like letters or parts of the word. You fed in input, next comes the tokenization, and then comes the embedding part of it. Each token is converted into numerical representation. I repeat, each token is converted into numerical representation with a process called embedding. This helps the model understanding the meaning of the words or tokens. First step is input, second step is tokenization, third step is embedding. Positional encoding is a very important step. The model does not naturally understand the order of words in a sentence, but positional encoding helps you in this task. It is added to each token's representation to show where it is located in the sentence. So it helps you locate it. Now comes the next step, transformer layers. The tokens with their positional encoding are then passed through multiple layers of special type of neural network called transformer. We discussed what is it. These layers help the model understand the context of each word or token by considering all the other words or tokens in the sentence. And comes the output now. After going through the transformer layers, the model will be able to predict the next word or the token in the sequence based on the context provided by the input text. And then comes the training and the fine tuning. The model is trained on a large data set of text to learn how to generate the text which will be contextual and which will make sense. It can also be fine tuned for specific tasks like translation or summarization by providing it with some simple examples, and that's very easy to go ahead with. So in simpler terms, GPT takes in text, breaks it into smaller pieces, understands the meaning and the order of those pieces, and then generates more text based on that understanding. I'll quickly repeat it. First is input, you give the input. Second is tokenization, it is broken into smaller parts. Third is embedding, each token is converted to numerical representation. Fourth is positional encoding, we do not know the position perfectly, so let's get that understanding using positional encoding. Then comes the transformer layers, all these tokens with their positional encoding goes through these multiple layers, then gets the output, and finally training and fine tuning for you to get better results. That is it. You know the GPT architecture right now. How did it start? It all started with the term attention is all you need. That is the detail and the self-attention mechanism. And then it went to GPT. The generative pre-training started. Then came the GPT-2. Multitask training was enabled. Then even bigger model GPT-3 was developed. Then Instant GPT came, which can learn from the human feedback. And then what you have in hand is ChatGPT, which is the superb evolution that we are all using. Now comes the BERT. What is BERT? BERT is standing for bidirectional encoder representation from transformer and is introduced by Google. By the year 2018 they introduced it, and it is designed to understand the context of the words very clearly in a sentence by considering the surrounding words. What do you mean by surrounding words? The words both before and after, which was in contrast to all the previous models where it was only sequential in nature. BERT has achieved state-of-the-art results in various NLP applications such as the text classification, entity recognition, named entity recognition, question answering and more. And this is very interesting and easy to understand as well. I'll show you a very simple piece of code here, and this code will help you in understanding how BERT is going to be very useful, and we need to have the previous necessary installations done with pip install transformers, pip install torch. These two are prerequisites for you to run this code. This code snippet is very simple and it demonstrates how to tokenize a sentence using BERT tokenizer and then obtain the contextual embeddings for each token using the pre-trained BERT model. You can modify the text variable. I have given a text there, so you can modify it and you can read in the code. You must have the transformers library and PyTorch installed to run this. I ran it in Google Colab. You can run it in Google Colab or Intel Developer Cloud. Wherever you want, you can run it, but make sure you have the transformers library and PyTorch properly installed. The first step is to get the transformers imported from the BERT tokenizer, BERT model. Then you are importing Torch. Then you are going ahead with loading the pre-trained BERT model and tokenizer. You can see that there. And then I am feeding in the sample text. Indian team will win the World Cup for sure. this time in the USA. Then we are tokenizing it. Tokenizer is used there and we are tokenizing it. Then forward passing happens through the model and then we get the output embeddings from the model. And finally, we are printing the output embeddings shape. And we have got the task size output as 117,768. You change the sample text, you will be able to see the output in a different way and you will be able to test it easily. Now, to understand the entire flow, the BERT architecture, we will have to go through the same way as we have learned with GPT. What is the first step? The first step is input. BERT takes the sentences as input, but it needs to understand the word first. It converts each word into a unique number, tokenization, and then turns those numbers into vectors. That is nothing but embeddings. I've used two very important terms here. One is tokenization and another one is embeddings. They are similar to the code words for each word. Now, understanding the context comes next. BERT uses something called as transformer. We have seen this in the GPT. It's like a brain for everything that we do here, and this looks at all the words in the sentence at once and figures out how they are related to each other. This is very, very important, and this is what we called as self-attention. I have explained you enough about it in the past. Seeing both sides happen next. BERT is very special. Why? It looks at the words from both the directions of the sentence at the same time. This way, it can understand how a word fits into a sentence by seeing what comes before and after it. That's very, very useful. I see before, I see after. Then comes the learning. Before it can do something useful and generate output, it needs to learn about the language. It does it by reading a lot of text and trying to guess the missing words in the sentences. It's like mask language modeling and then deciding if two sentences follow each other. The next sentence prediction happens here. And then adapting to tasks happens. Once it's learned about the language, BERT can be trained for different jobs like answering questions or deciding if the review is positive or negative. It just needs a little bit of extra training that is called as fine tuning, and it can understand and can help you out with the proper results. And finally, it gives you answers. After all the learning and training, BERT can finally do this job and it can take a sentence as input and understand very clearly using what it has learned, and finally it gives answers or predictions based on understanding. That is it. It takes input, it understands the context, it sees both the sides, it learns, it adapts to the tasks, and it gives you answer, and that's BERT for you. Now quickly we'll summarize. What is BERT? The purpose is very simple. Bidirectional encoder representation from transformer is mainly used for understanding meaning of a given text in various NLP tasks like text classification, named entity recognition, and question answer. How it works? Very simple. I told you this. It reads the text bidirectionally, meaning that it looks in both the sides, the left and the right, the word before and the word after it looks, and that's how it works. BERT is pre-trained on a large amount of text data with supervised tasks like Mark's language modeling and next sentence prediction. You can fine tune it as you wish. Use cases can be many, and you can understand and analyze text. You can go ahead to the sentiment analysis using BERT. Document classification can be done. Language translation can be done. All these with BERT. Now coming to GPT. GPT is used for generating new text. That's a major point. Based on the prompt or the context that you have given, it will be able to generate new text. GPT reads the text from left to right, predicting the next word based on the context it's been given. It's like fill in the blanks. That's the simplest way somebody can understand it. GPT is trained on a large corpus of text with a language modeling objective, and it has learnt everything from there. It doesn't need fine tuning for specific tasks. Text generation like story generation, summarization, dialogue generation, all these can be very easily done with GPT. To put it in very simple words, BERT is like a reader that understands text, while GPT is like a writer who can generate text. They both use the transformer architecture but are trained and used for different purposes. I hope that was very useful, and in case you have any questions, go ahead and ask me in the chat section. I'll be very happy to clarify. Thank you very much.